Okay, so welcome back. And the next unit that we're going to be talking about is thermodynamics. Excuse me. It's chapter 17 in our text, thermodynamics, and really we're talking about the science connected with the relationships and relations between heat and mechanical energy or work. Okay, the thermo, you know the term thermometer. It measures temperature. Heat, mechanical energy work, we're going to be looking at that. It is important that you realize that heat is not equal to temperature. A change in heat could be a positive or negative temperature. So often when we hear the word heat, we think, oh, it must be hot. The term heat does not define that it's getting warmer. It could be a negative temperature change. When we have a change in heat, we could have a negative temperature change. The temperature is dropping, so it's getting colder. So just please don't get confused with the term heat being hot, all right? So that's important to recognize as we move along. Excuse me. Heat transfer or energy. We're going to be seeing enthalpy and some different terms related to heat. The first here is this heat transfer or energy. So again, we're looking at energy. Heat transfer is going to be in a unit of energy. We're going to be seeing it in a second. But basically, the formula, we can calculate the amount of heat transfer by taking the mass, multiplying it by the change in temperature, and multiplying by the specific heat. Now, it is important to know what specific heat is. I think we know what a mass is. I think we know what the change in temperature is. Specific heat. Specific heat is the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. So if you have exactly 1 gram of a substance, to make that temperature jump from 24 to 25 degrees, that 1 gram, the amount of heat needed would be the specific heat for that substance. Now, different substances have different specific heats. Obviously, a substance like water has a high specific heat. It takes a lot of heat to raise the temperature of water by one gram, let's say, raise the temperature of water by 1 degree Celsius, as opposed to something like a metal, let's say iron. Iron has a very low specific heat, because if you put the same sun on iron and on water, the same amount, the same grams, the temperature is going to go up on the iron a lot more rapidly and a lot more temperature change than on the water. Okay, so again, if I were to draw this here, we've got our swimming pool. All right, and you know, even a deck that's made out of wood, here's my deck. Okay, if this is made out of wood versus, of course, the water, we have our same sun beating down. All right, so we're not changing the amount of heat coming down in there. But even if we had the same mass of our water and wood, our wood's temperature would increase more than the temperature of the water, because the specific heat of the wood, and again, iron or metals or anything like that is a lot easier. You know darn well, you feel a hot metal that's been out in the sun, the same sun that some water has been in, even though the metal may even weigh more, or way less for that matter, the water is going to be a lot cooler still. So you can certainly, feel like you can jump right in and feel like you're going to be refreshed. The specific heat of water is an important number to know. I'm going to give it to you in joules. The specific heat, the variable I use for, let me rewrite this here. The variable I use for specific heat is S, and I'm going to put water, is 4.18 joules per gram degree Celsius. And that label, that unit makes sense, right? Joules is a amount of heat is in joules, needed to raise 1 gram by 1 degree Celsius. So 4.18 joules per gram degree Celsius. Okay? Well, we can get a little bit more specific, 4.184, but 4.18 is certainly good. So that's heat transfer. Now, before I move on, or that's specific heat, I should say. Before I move on, I do want you to recognize the formula. Here's my formula, but we can write that as Q. Q is our heat transfer. That's the variable we're going to use, is equal to the mass times the change in temperature times the specific heat. Oftentimes in different, in like physics books, you might see specific heat in C as a variable. We use S. Okay, so there's your formula. I could very easily do a calculations for this. Notice if I say that you have 700 milliliters of water, and the specific heat of water is 4.18 joules per gram degree Celsius. If there was 5,000 joules added to this system, what would be the change in temperature of the water? All right. So you have 700 milliliters of water and 5,000 joules of heat is transferred to that. What's going to be the change in temperature? Well, here's my formula. Let's rewrite it. I'm looking for change in temperature. So change in temperature is going to be Q over the mass times the specific heat. Hopefully we know how we got to that formula. I divided both sides by the mass times the specific heat. That cancels it here and gets the change in temperature alone. And then I get this formula right here. I can now, let's grab another color here. Nice green, I think we'll be able to see. To solve for the change in temperature, it's going to be that 5,000 joules divided by the mass. Now I gave it to you in milliliters on purpose. We should know that the density of water is 1 gram per milliliter. Let me write that over here. Density of water is 1 gram per milliliter. That means if you have 700 milliliters, you also have 700 grams. So 700 grams times our specific heat, 4.18 joules per gram degree Celsius. I do all the multiplying on the denominator and then divide, and my change in temperature in this situation is 1.71 degrees Celsius. Okay, obviously I could ask for any of these three variables, specific heat included, even though it's specific to what it is. But that's the straightforward formula. Mass is going to be in grams. You need that in grams per unit. Change in temperature is in degrees Celsius. And the reason is because our specific heat is in joules per gram degree Celsius. We could see it in calories. We're going to use joules since we're going to use SI units. And of course, that means that's the heat transfer unit is in joules. So that's heat transfer, a little bit about energy.